Bismillahir Rahmanir Rahim. Assalamu alaikum, dear students. Hope you all fine. Dear students, this lecture is for grade 10, subject chemistry. And in this lecture, we will discuss the last chapter, chapter number 16, chemical industries. This is my 32nd lecture, and I am your lecturer, Mrs. Saira Jamal. Dear students, the major concepts of this chapter are basic metallurgical operation, solvay process, urea, and importance of fractional distillation of petroleum. Coming towards the first topic, that is about the basic metallurgical operations. First of all, you must know what is meant by metallurgy. So the process of separating a metal from its ore and preparing it for use is known as metallurgy. The process of separating a metal or extracting a metal from its ore and preparing it for use is known as metallurgy, and all the steps which are used for this purpose are called metallurgical operations. Now, the term ore, the process of separating a metal from its ore and preparing it for use is known as metallurgy. So you must know what is meant by ore. An ore is a solid deposit containing a sufficiently high percentage of a mineral to make extraction of metal economically feasible. So you can say ore is a mineral which contain a high percentage of our required mineral which we use for other purposes. So like what is mineral then? The naturally occurring metallic compounds are called minerals. Like all the naturally occurring compounds, like you can say aluminum, we can say lead, all metals, aluminum, lead, like iron, all these metals, they are present in our surrounding and in the form of compounds. Mostly they are present in the form of compounds, and those compounds, as they are present under the earth crust or in mountains or in sea, so they occur in the form of metallic compounds, and those metallic compounds are then called minerals. So after different steps or different processes, the metal in pure form is extracted from those minerals and those ores, and then we use that pure metal for other purposes. So the thing, there is a little difference between the minerals and ore. Let's discuss that difference. What is the difference between mineral and ore? Mineral, we extract it or we dug it out from the under the earth crust or from mountain or from we take it out from the sea. So what is the difference between the two? So the main differences between the two are that all the naturally occurring substances of metals present in the earth crust are called mineral, but that mineral which contain or which can be used to obtain the required metal profitably. Profitably means like in large amount, and it is less economical, like it is less expensive method and a cheap method to take large quantity of our required metal from that mineral. So that part of the mineral or a rock. Suppose if we dug out a rock from under the crust, and that rock, one part of that rock contain a large quantity of aluminum. Suppose if we are taking the example of aluminum, large part of aluminum over there, but aluminum is not alone. It is in the form of aluminum oxide, which is called bauxite. Al2O3 is the ore of aluminum, and it is called bauxite. Cryolite is also the ores of aluminum. So because they are called the ores of aluminum, because these are the compounds of aluminum, in which aluminum mostly exists in the earth crust. So that part of the rock which contain more aluminum oxides or aluminum, the ore of aluminum cryolite over there, then we can call that mineral as ore. So all minerals are not ores, but all ores are essentially minerals. Example of mineral is clay. Clay is the mineral of aluminum, but clay contains little aluminum in it, and we cannot use clay to extract pure aluminum from it. While the bauxite and cryolite are the ores of aluminum, and they contain high percentage of aluminum in it, so we can use these ores, bauxite and cryolite, to extract pure metal from bauxite and cryolite. So the difference between mineral and ore is that mineral contain less percentage of the metal which is required, and it is expensive. You can say it is not economical or not a best method to extract that metal from mineral, because it will just give you small percentage of the metal. But ore contain large proportion or high percentage of the metals, and by doing those metallurgical operations, we can get maximum percentage of or high percentage of pure metal from there ore. So mostly for the extraction of metals, we use ores. We use ore, not the minerals. Metallurgical operations, there are different steps. I told you all the steps which are involved for extraction of metals from its ore, which is called metallurgy, are called metallurgical operations. So the first metallurgical operation is crushing, grinding or pulverizing are same. Grinding or pulverizing of the ore. First of all, the ore which is extracted from the or which is removed from the mineral or separated from the mineral. That ore is then, first of all, it is crushed and then grind into fine powder form. It is called pulverizing. Pulverizing means grinding the ore into powder form. Then the second step is concentration of that ore, then extraction of metal from the ore, then refining of metal. These are the four important steps which are used to extract metal from its ore, and all these steps are called metallurgical operations. You can see in this image the ores are first crushed out, and then they are pulverized. You can see the powder form of the ore. These are the crushed form, and after crushing, then they are grinded or they are converted into powder form. So we call it pulverized ore. So you can see this is pulverized ore, and the other parts, the long stones parts, are, you can call them the crushed form. So the ores are first crushed and then pulverized. This powder form is now called pulverized ore. Second, after crushing, grinding, and or pulverizing, the second step is concentration. After mining, mining means digging the ore. Through crushing, grinding, or pulverizing steps, it is converted into the powder form. Then this powder form is used to separate mineral and the gangue by some physical method. Gangues are actually the extra substances or materials which are present with our metal or with our like the required metal. So we have to remove that GAN or the extra particles from our metal, and we use different method. Then some of the method are the first one you can call that this process is called overall called concentration, and there are certain methods which are utilized to remove the gangs from the minerals. So this process is called concentration, in which the gangs and the minerals are separated by some methods. And this process is the concentration. What are those methods by which the minerals and gangs are separated from each other? These methods are: number one, the first method is called magnetic separation. As from the name indicated, or it is clear that the magnetic mineral will be separated from the impurities or from the extra substances by magnetic separator or by the use of magnetic separator. For magnetic ore, a magnet is used to remove mineral, leaving the gang behind. What they do, actually, they pass the powder ore. It is dropped over a moving belt, and then the belt moves over two wheels One of the wheel is magnetic. So the magnetic wheel will attract the magnetic ore, and then those magnetic ore will fall nearer to the magnetic wheel, while the non-magnetic impurities will fall further away. You can see this process in this image. These are the magnetic belt, and the magnetic belt is placed on two wheels, or it is fixed on two wheels. One wheel is non-magnetic and the other wheel is magnetic roller, or you can call it magnetic wheel. And then what will happen, this finally grounded ore, or you can say the pulverized ore, it is passed, or it is yeah, it is passed through this magnetic belt, and then after passing through the magnetic belt, when they reach this second magnetic wheel, what happens, this magnetic wheel will attract the magnetic particles. Those magnetic particles, due to the attraction of this magnetic field, will fall down in the nearer container, or in the closed container to this magnetic roller or magnetic wheel, while the non-magnetic particles or impurities, as they are not attracted by the magnetic roller, they will fall down, or they will fall down into the non-magnetic container, or this second container, which is farther away from the magnetic belt. So first of all, the finely grounded ore, which is also called pulverized ore, is passed on this magnetic belt. This magnetic belt has it is placed on two wheels. One is non-magnetic wheel or roller, while the second one is magnetic wheel or roller. When the pulverized ore passed on this magnetic belt, and when they reach to this magnetic roller will attract the magnetic particles. Those magnetic particles, due to the attraction of the magnetic roller, will fall down, or it will fall down into the nearest container, while the non-magnetic particles will fall down in the farther away container. By this way, the magnetic and non-magnetic particles can be easily separated. Second method of concentration, or to separate mineral from the gangue, is cyclone separation. Cyclone, for this purpose, or for cyclone separation, the cyclone separator is used. And what is the principle of this method? The principle of the method is the large density difference. It means heavy particles and lighter particles. It's understood that the heavy particles, they are heavy. So due to the centrifugal force, they will settle down at the bottom of this cyclone separator, while the lighter particles, which are the impurities or which are the dust particles, they will, you can say, expelled out or removed out with air, and leaving behind the minerals or the denser particles of the metals in the bottom of cyclone separator. So where large density differences mean some particles are lighter, I mean less density, and some are denser or heavy, they have a higher density. So the high density particles can easily be separated out from the low density substances. Where large density differences exist between ore and impurities, ore are denser than the impurities, so a cyclone separator is used. In this method, air under high pressure is blown through the pulverized ore. Air is passed through the pulverized ore or the powder ore. The lighter gangue is blown away through the top because they're lighter in weight, and then they will go along with air to the top. But the denser mineral rich particles hit the walls by centrifugal force, and then they will fall down in the funnel of cyclone separator. In this image, you can see the cyclone separator. This is the cyclone separator. This is the cylindrical part. The lower one is a cone part, and this is the pipe through which the gas or the air which contain minerals and along with the impurities or dust particles or sand particles are present, they are then passed through this cyclone separator. So the dirty air means the air which contains minerals along with the impurities with it. When it is passed through the cyclone separator, what happened due to the centrifugal force, you can see this round movement of or this special type of movement of air inside the cyclone separator, because this cyclone separator will move, and due to the movement the air in this cyclone separator also rotate or also move, and due to the principle that the denser particle present in this air will settle down in the conical section of this cyclone separator. This is called cyclone separator, and this is the conical part or conical section because it is like a conical section of the cyclone separator, and this cylindrical part is called cyclone body. So you know that the air which is moving in this direction is also called cyclone. So that's why it is called cyclone separator, because the principle is same like the air. That the air, when it will move with a greater speed, what will happen? Because the cyclone separator rotates. Due to the rotation of the cyclone separator, the air inside this conical section, it will also move like a cyclone, and the denser particle will move down in this conical section, and we can collect it from this opening, while the air which contain the dust particles or impurities in it, they are lighter in weight, they will move along the air and will expel out through this opening. That opening contain the impurities and the air over here. This clean air actually is mentioned because this air which is mentioned here is actually the air which contain impurities in it. But the clean air which is mentioned here is for the purpose that cyclone separator is also used for cleaning air. Because if we just pass normal air in cyclone separator, so normal the dust particles, the impurities which are present in normal air, it will settle down at the bottom and clean air can pass through. But in this case, for metallurgical operation, this cyclone separator will be used for extraction of metal. In this case, the impurities mostly are sand particles or some dust particles. So those sand particles and dust particles are lighter than the mineral, or then definitely the lighter particle will go out along with air, and the denser mineral particle will settle down at the bottom, and from the bottom we can collect the mineral. So this is about the cyclone separator, one of the concentration method by which the mineral can be separated out from the gangs or from the impurities. Third method or third process of concentration is flotation process. Flotation is again one of the process by which gangs are separated out from the mineral. In this case also we will use the pulverized ore, mean the powder ore. Pulverized ore or powder ore is fed into a tank or put into a tank. That tank contain water and oil detergent mixture, oil, little detergent and water and pulverized ore. A mixture of all these. A mixture of powder ore plus water plus oil and plus detergent in it. So this is a mixture of four substances. This mixture is then passed through the tank and then it is agitated with air. Air is passed through this tank which contains this mixture, and along with the passing air, this mixture is agitatedly mixing electrically or by electrical stirrer. The mixture is agitated or mixed. What will happen after mixing the mixture? The detergent means oil and detergent mixture, it will wet the mineral particle or react the mineral particles because they are non-polar. You know, the oil is non-polar, and the non-polar will make bond with the mineral particles. But not the silicate gang. The silicate gang are polar in nature. They will react with water. The mineral particle will react with oil, with the oil detergent, while the silicate gangue will react with the water. So the silicate gangue, when they react with water, so you know that water is denser than oil, and oil is lighter. So oil along with the mineral particles will form froth or will form lather and will come at the surface. While the gangue like silicate gangue and the water, they are denser, so they will settle down at the bottom. The mineral along with the oil or detergent particle will move at the surface, and from the surface we can collect that mineral. So by this way the impurities will settle down at the bottom, and the pure like so you can say mineral will go at the surface. So the particle of the gangue fall down to the bottom because they are denser, they are heavy, and the copper ore is concentrated generally by flotation process. Mostly which the ore of which metal we concentrated or we clean it or we remove the impurities from it is mostly the copper ore. All the copper ores are concentrated by using this flotation process. You can see in this image, this is a tank which contain a mixture of oil, detergent. Which oil is used? You can see here water containing pine oil, and you can also see the water, and mostly this process we use for the copper sulphide, because they say sulphide ores particles are mostly separated by this flotation process. So if, as I told you, for copper ore of copper like copper sulphide or lead sulphide or galena, which is the ore of lead, we mostly use this for flotation process for the concentration of sulphide ores. So actually sulphide ores, they make bond with the oil, or they are attracted by the oil, and the gangs or the impurities are attracted by the water. So what will happen, as I told you, air is passed through this agitator, and this agitator contains holes in it. So the air will come out through these holes. When the air will come out through these holes, it will collide or strike the mixture particles. So after collision of the mixture particle, what will happen? The oil and detergent will react with the mineral, and the gangs will react with the water. And as the gangs and the water, they are denser. So you can see the black dots. These are for the gang. They will settle down at the bottom, but the sulfide ore and along with water and sorry, sulfide ore along with oil, because pine oil actually reacts with the sulfide ore. They are lighter, and they will make froth or leather and will come at the surface. So that froth, which contains sulfide ore particles, they can easily be skimmed off or drained off from the surface of this tank. So this process is called froth, a flotation process, because froth is formed, or leather is formed in this process because of using the oil and detergent. After the first step was in metallurgical operation, the first step I told you, it was crushing, grinding, or pulverizing. The second step was concentration of ore, but in a concentration of ore, we discussed three processes which are used for the concentration purpose. Concentration, I told you, means that separation of mineral from gangs or from impurities. So we discussed three methods. The first one was that is the magnetic separation. The second one was froth flotation, and sorry, cyclone separation, and the third one was froth flotation. Now, after concentration of mineral, the third process is extraction of metal. So, extraction after purification or removing impurities from the mineral. Now, extraction of mineral from its ore after the mineral has been freed of gangue. and concentration. After concentration process, which result in the removal of all gangs or impurities from the mineral. This mineral is then passed through some chemical processes or some chemical reactions to extract the metal. The first method is roasting. As from the name, it is clear that from the name it is clear that how can we remove the how can we get the metal from its ore. So some minerals are converted to oxides by heating in the air, in the presence of air at high temperature. What will happen, the temperature below their melting point, not at that temperature you have to heat to melt it, just heat them below their melting point. So this process is called roasting, heating of mineral in the presence of oxygen at high temperature, but that temperature must less than their melting point. So this process is called roasting. For example, the roasting of ore of zinc, which is called zinc blende, that is the ore of zinc, and it is called zinc sulphide. So zinc sulphide is when heated in the presence of oxygen, it gives a zinc oxide, like the oxides of zinc, and sulfur dioxide gas is produced. So these sulfides are converted into oxide. By roasting process, what happens? Minerals are converted to oxides by heating in the air. So you can see sulfides are converted into oxide. In roasting process, sulfide minerals are converted into oxide. So zinc sulfide is converted into zinc oxide by heating at high temperature in the presence of oxygen. Then roasting reaction for cinnabar. Cinnabar is the ore of mercury. You can see mercury sulfide, and this is cinnabar. And this mercury sulfide, it is heated in the presence of oxygen and will give metallic or pure mercury along with sulfur dioxide. So we can get pure mercury, or we can extract mercury from the sulfide of mercury by heating or by roasting process. Roasting reaction of copper pyrite or of copper pyrite. You can see copper iron sulfide. This is known as copper pyrite. This is an ore of copper. When it is heated and in the presence of oxygen, it will give copper sulfide and iron sulfide and sulfur dioxide gas. Still, you can see that the copper pyrite is not converted into oxide. In this step, it is just converted into sulfide ore. But for the extraction of metal from its ore, it is compulsory to get first the oxides of ore. But by this process, by roasting this copper iron sulfide, which is also called copper pyrite, it give us only sulfides, copper sulfide and iron sulfide. But as I told you, we need oxides of copper, so then that oxide of copper will give us the pure copper or metallic copper. After roasting, the next step is smelting, except the copper sulfide, which is not in the oxidized form. The other metals, which are after roasting, are converted into their oxidized form. Then the smelting process is taken place. The method to reduce metal ions to free metal is called smelting. This is, I told, this is for the other metals which are in their oxides form. The most they are then in smelting process. What happens? Those oxides of metal, like as I told you in case of uh, the zinc oxide, or iron oxide, those oxides of metal, they are now reduced into their metallic uh, uh, form, or in their free form, or in their pure form. And how this process takes place? This process takes place by the reduction of those oxides of metal. And the reduction of oxides of metal take place in the presence of some reducing agent, because you know that those substances or those elements which can oxidize by themselves and reduces other are called the reducing agents. So the most common reducing agent which we use in smelting process are coke. means carbon monoxide, and hydrogen. These three mostly are used as a reducing agent, and these reducing agents actually reduces the oxides of metal into their metallic form. You can see this is iron oxide, which is also called hematite, and this hematite or iron oxide is treated with the carbon monoxide, which is a reducing agent, and this carbon monoxide will reduce iron. You can see iron is converted into free iron form or elemental iron form. So you can see that loss of oxygen by iron is called reduction. So iron oxide is reduced in metallic form, while carbon monoxide is oxidized by gaining oxygen. You can see will form carbon dioxide. So after roasting, I told you except copper, because in copper, in roasting, the copper is converted into sulphide form, not in the oxides form. But for smelting, we need the oxides of metal. So except the copper, the other metals which are converted into their oxide form in roasting process, they are in smelting process are reduced by using the reducing agent, and after reduction, they are converted into their you can say free form or in their pure metallic. Tungsten oxide, again by using another reducing agent, that is hydrogen. I told you hydrogen can also be used as a reducing agent. So hydrogen will reduce the tungsten oxide and will convert it tungsten into metallic tungsten or in its pure form, and then hydrogen will oxidize to form water. One more example is for zinc oxide, as again it is in the oxide form. So zinc oxide, after reducing by the coke or carbon, is converted into metallic zinc and carbon monoxide. So in smelting point, I told you is actually the conversion of the oxides into their metallic form. Now coming towards the copper, as I told you that the roasting of copper will not give us the oxides of copper, it will give us only the sulfides of copper. So however, smelting of copper ore is done in two steps. After roasting, the smelting we will do in two steps. First step definitely is conversion of those sulfides into oxide. So the roasted copper, like which we roast in the roasting step, in smelting, what we will do, the roasted copper ore is heated with coke and sand. Not only with coke, it is heated with coke, the reducing agent, and also some sand is added in it. We add the sand because we want to remove the sulfide from the copper. So to remove the sulfides or to remove the iron sulfide, which was also present as a mixture with copper after roasting of the the copper pyrite. Copper pyrite, I told you, iron sulfide and copper sulfide both are formed. So we want to remove these iron sulfide from this, which is present as a mixture with copper sulfide. So how can be it removed? It can be removed by adding sand in the roasted copper, or plus we will add coke, plus we will add some sand in it, and then we will heat it at 1100 degrees centigrade. What will happen? The material melt and separate into two layers. It will give us two layers. The bottom layer that contain mixture of copper sulfide and iron sulfide is called matte. A mixture of copper sulfide and iron sulfide will form, which is called matte, while the upper layer is a silicate slag formed by the reaction of iron oxide and sand. Some of the iron oxide, because as we are heating the roasted copper or the roasted copper, which contain copper sulfide, iron sulfide, and some of the iron sulfide will react with the oxygen of air and will form the iron oxide, and that iron oxide will form react with sand. That sand and iron oxide will form iron silicate. Iron silicate. Iron silicate is called slag, and that slag actually we can use that slag as a fertilizer. So that slag is you can say lighter than the mixture of metal, because still some of iron, not all of the iron will you can say converted into oxide form, as in the first roasting process some of the iron sulfide was removed, but some or the remaining iron sulfide is removed by this process by reaction with first it will react with oxygen, it will form iron oxide, and then iron oxide then will react with sand and will form the slag. So over here you can see ore, the powder ore, roasted ore, coke, carbon, limestone, that is I told you the calcium carbonate can also be used over here. So the sand or calcium carbonate will also remove out the iron in the form of slag. Slag actually is the lighter air of mixture of iron and that silicon or calcium carbonate. So the molten metal which contain iron sulfide and copper sulfide will settle down at the bottom in the molten form, and we can drain it out in this through this opening. Then the iron sulfide which is present in with the copper sulfide, it will react with oxygen and will form iron oxide. And iron oxide, as I told you, will react with the sand or with the silica and will form iron silicate, which is called slag. This is the formula of slag, iron silicate. And this layer can be removed easily by this process. So the next process is basimerization. Basimerization, inshallah, we will discuss in our next lecture. So this was all about the metallurgical operation. Inshallah, this process, this next step of copper extraction of copper from its ore, we will discuss in our next lecture. So till then, take care. Allah.